Hello, good afternoon. We can wait a few minutes before we start. The webinar should start at 2 o'clock, so we give some time for the participants to join. Can you all hear me okay? I'm just making a little test here. Thank you. Dr. Michael, you can put your slides if you want, just to have them set up there. Feel free to do it.
Sounds great. All right. You see that main page there?
Yep, that's right. It looks good. Thank you. We have a few minutes more to wait for other participants to join. Just I would like to remind to please mute your microphones before the presentation start. Thank you. We'll give a few minutes more, and then we will start. Um, I'll give the signal. And I'll let 1 minute more, and if that's okay, um, we can start so we respect the participants' time during the session. Thank you. Okay, I think we are going to start now, and we will accept the participants joining as they come. But this is good time. It's 2:02. Thank you, everyone, for joining this afternoon, and welcome. Oh, more people joining right now. Welcome to our pollution prevention webinar series. Um, Today's webinar is about water conservation, reducing and reusing water in manufacturing facilities. This webinar is hosted by the Center for Sustainable Energy and Environmental Engineering, and also the EPA Pollution Prevention uh, Program. My name is Marley Carmona, and I'm going to be the moderator this afternoon. And just a little bit of more information about me. I was just recently hired a few weeks ago as the new pollution prevention specialist for the center. See, I think we can move this slide to the next one. And the mission of the center is to promote the use of renewable energy technologies and the conservation of natural resources to enhance the industry awareness and serve our North Carolina communities. Next. Thank you to the EPA Pollution Prevention Program and Source Reduction Assistance funding. The center is able to offer and facility multiple options to support our businesses across North Carolina. Some of those include on-site energy and lean assessments, regional and on-site B2 energy training, regional workshops, technical and engineering support, cash flow and market analysis, and also return on investment. Next, please. So before we start, please know that we're going to be recording this series. And also at the end of the session, we can provide the presentation from the speaker. We can send a copy to your email. And also, please feel free to ask questions and provide feedback at the end of the session. We're going to have a space for questions, but you can also use the chat. And as you go through the presentation, please leave your question there, and Dr. Michael will address it at the end. So next. So now I would like to introduce our speaker for today, Dr. Michael Hayes. He's an assistant professor for Louisiana State University Agricultural Center and Louisiana Sea Grant Water Quality Specialist. He currently runs the LSU Water Quality Extension Lab and is also the director of the LSU Ag Center USDA-funded Water and Energy Conservation Program. Dr. Hayes' expertise ranges from agricultural water quality to best practices in industrial water conservation. His research focuses on practical solutions to persistent water programs around the state of Louisiana. He's been working on developing detection and extraction techniques for current and emerging contaminants in the agriculture industry, also developing water use reduction techniques, as well as waste minimization protocols and studying nutrient dynamics for urban to coastal ecosystems. Please, before I continue, I would like to remind to mute your microphones. Thank you. So Dr. Hayes' team approaches is a variety of water quality topics ranging from agricultural to coastal and everything in between. So thank you for joining us today, Dr. Hayes, and we are ready to start your presentation. Please feel free. Dr. Hayes, please unmute your microphone. Thank you.
Thank you so much. I'm so sorry. I really appreciate everybody tuning in today, and thank you so much for that introduction. I'm really excited to give this presentation today, and really hope it serves as some ideas of best management practices in our state and where some of these water conservation techniques can be applied. So as Dr. Corona said, I'm MP Hayes, Assistant Professor for Agricultural and Industrial Water Quality here at LSU, and run our Water Quality Extension Lab. So today's lecture topic is going to be focusing on reducing and reusing water in manufacturing facilities.
I think you're muted. You're muted again.
I am so sorry. I don't know why I'm having so many problems with the system, but thank you. My teaching appointment is a little tricky. It's only 5% teaching, 25% research, and 70% extension, and dual appointed between LSU Ag Center and Louisiana Sea Grant. So this gives me a really great opportunity to work with all different walks of life here in Louisiana, the agricultural world, coastal, and industrial sector. And also with this teaching appointment, it gives plenty of time to work with different communities and provide impactful research and dissemination to those different areas. All right. So one of the big goals that our program looks to institute is synergizing the resources our state has. So we look for these individual sources and able to scale science to larger audiences through this technical assistance. And this is state scale collaborations between academic, industries, and agriculture that leads to global discovery and hopefully, amplified on a national scale as well. And this comes from working with a vast range of different industries within our state. So you'll hear me talk about quite a few different diverse groups of manufacturers that we have. And any one given day, we could be at an alligator processor and then turn around and be at a chemical facility 2 or 3 days later. So it offers a really interesting perspective on what manufacturing footprint looks like in our state. So the water quality extension lab we look for finding persistent problems around the state and then crafting these practical economic solutions that can benefit the economics from an industrial perspective or community. And again, we start with that single stakeholder, and then after we come up with recommendations and possibly do implementation, we disseminate this information across the extension platform. And so this happens with association meetings, again, recently with alligator processors, all the way up to these field days and workshops to help train these different areas of industries in recommendations that were initially tailored for one facility. So we find these applicable areas that the same recommendation might be able to be applied to, and then broadcast those on a larger scale to a larger audience. And then overall, incorporating the students into this process really opens the doors to make a difference in their field, for creative solutions to problems. You'd be amazed at what some of our students kind of think up when they're on site with us for these assessments. And this is all made possible through our experiential learning programs. So here we have multidisciplinary teams that go out to the field. We've got energy experts, sustainability experts. I'm on the sustainability side where we look at pollution prevention, water reduction, alternative chemicals, waste minimization. And again, we service pretty much the entire state of Louisiana in multiple different industrial fields. So shipbuilding, steel fabrication, ag, chemical, and even commercial facilities have a sustainability footprint that they're looking to reduce. And then the training that we get from the undergrads and the graduate students, again, enhances kind of how we come up with these creative recommendations. And this is a shameless plug for all of the programs out there, but EPA does such a great job with their P2 series. And so we really encourage, no matter what manufacturing sector you're in, to look out for some of these funding opportunities at universities in your area. So these agencies do a really great job funding these TA programs and getting opportunities for workforce development, internships, and these no-cost assessments at facilities. So definitely find one in your area, especially if you like some of the recommendations we talked about today. So our lab, again, the focus is reducing and reusing water today, but to show you kind of a variety of recommendations that we make, we dabble in quite a few different areas. We've recently been implementing floating solar panels for agricultural irrigation pumps for water conservation. So looking at ways to reduce evaporation runoff, improve your pond health by decreasing algae, and then possibly providing this on-site power for agricultural farmers to reduce their diesel footprint. Some of our chemical facilities, we use waste steam to evaporate out and condense materials, and that's a byproduct reduction. This comes from their stormwater collection areas mainly. Eliminating the practices of mixing waste streams is a really big one we see down here, and this can increase the cost of your disposal. And we see this as an opportunity for processors to start having different waste streams that they can possibly do something with or treat on site. And then finally, into more of the real-time data sets, we offer implementation of real-time water quality monitoring to optimize energy and water quality parameters from wastewater aeration. And this is a really big thing we're pushing right now to introduce new technology into industries and showcase the ease at operating and maintaining some of this newer technology to hopefully be more proactive when it comes to maintenance instead of reactive to the problems we see in water quality. So today, when we zero in on these reducing and reusing techniques, one big thing we always discuss with facility partners when we're working with them is knowing kind of their mindset when we go in. So that's, what's your facility footprint look like? Are you using 30,000 gallons of water per month? Or are you using 500,000 gallons a day? Knowing that really helps kind of target solutions to the problems on site. Also, what the water goals are for each of these different industry partners. Are they looking at just learning what opportunities are out there so they can start the process and thinking what sustainable future looks like for them? Or are they ready to implement? Are they wanting to do a reduction percentage of 10% water reuse, 20% water reuse, 30 and above? And a lot of people think this is the same question, but why are you undertaking the project? That's a very different than what are your goals. So sometimes with our processors, we might see that they're in a water burdened area and they're trying to help the local communities with water. Sometimes it's they've got sustainability partners, maybe somewhere in Europe, that are looking at life cycle analysis and they're trying to have a more sustainable footprint. Sometimes it's compliance. There's a ripple effect from something happening in another state that a processor wants to get in front of. And so these are all questions we like to know so we can target the solutions to be practical for them and to grow on a long-term scale. And from an academic mindset, the academics that might be on this talk, what we really do from my end of things in my lab is we try to look at the available resources that I have as a faculty member that we can offer these industries to really help with their water problems. On the flip side, we're also looking at our state's leverageable industrial resources. And what this means is there's a lot of waste out there, there's a lot of water problems, but we have the time and ability to apply some research to there to come up with these practical opportunities to disseminate back to these communities. So we're always looking for opportunities with casting sands and waste products for agricultural use and seeing if we can partner industries across our state to have a waste valorization system. And finally, you want to balance the innovative and practical. It's really easy to tell a facility they could tear down and rebuild for $15 million, but we want to give them some practical solutions for the short term and then a sustainability plan for the long term that will help them overall in their process. So today, again, just talking a little bit about, concurrent rinsing as a reducing water in your facility, and then examples of water reuse in multiple different types of facilities here in the state. This is just to give ideas for possible projects in your particular facility or your particular research area. And you'll see quite a few diverse types of manufacturers throughout the next few slides. But as we're talking and as we're kind of getting ideas, really think here about your facility footprint. Again, what does water look like in your facility and how would you like to change that footprint? So for concurrent rinsing, really the best definition for it, and one of the harder things to find online about this process, a standard rinsing process. So this is what a typical shrimp processor in our neck of the woods looks like. You've got an input water at each stage or each major stage of your process. And so each of these input waters has a flow coming in, and then they have a wastewater effluent stream going out. And so this leads to a large total volume of effluent that ultimately is a diluted form of whatever's coming out of that facility. A concurrent rinse process would be an input water at one of the final stages. You can classify it as the beginning stage of the water cycle. And then it would flow backwards through the process, concentrating the waste materials and then leading to a concentrated wastewater effluent stream. And so these are some of the tactics we look for is where can water be turned around in the process or reused in a concurrent rinse. Now, there are many different diverse ranges of concurrent rinsing practices in all the facilities we've been to. And some of the other ones that we've seen, just pulled a few of these pictures. For a rinse process, we see these overflow tanks where product might come in and get rinsed going up. The water then flows over the top of these containers going down and gets more concentrated as it goes down through the process. This gets pumped out and then ultimately to a wastewater effluent stream. In other facilities, we've seen the same type of tank design system, but instead of an overflow, you've got a pump that sends it from one tank to the next. So as parts move in, the water gets cleaner and cleaner until the final stage, and the clean water is then pumped downstream to the dirty water process and then out to the effluent. So again, you have many different types of how concurrent rinsing would be set up, and it kind of depends on the scale of your facility and what you're looking at doing with your water. So the first really good example of this, and really the only one I've actually seen in practice to this scale, was at a steel fabricator in Louisiana. I reached out to this company before I gave this talk, and I want to give them a shout out. John Deere was probably one of the most progressive companies I've ever been to from a sustainability and energy footprint. And they do a really good job looking at some of these larger equipment changes in their process. And so we saw this awesome concurrent rinse setup. It was pre-paint sprayer. So as all the parts are being moved to their facility and crafted and welded, they get dunked in these tanks as they go into the paint sprayer to remove all the oils and greases that remain on the products. Now, in this setup they had multiple tanks, I think 4 or 5 of them. With the concurrent rinsing they had pumping from one end to the other, they really just use a fraction of water volume compared to a normal facility. So they're only sending the last tank to outflow, whereas they're constantly filling that up with the dirtier water from the end of the process. So this was a really great best practice to look at. It was a really good opportunity for them to save water, have that nice positive impact for the water burdened area they were with, and cool for us to see. But it is a very large capital cost that has to be planned for a facility of this magnitude. Again, with the rinsing cycles, another one of the steel fabricators in our state is a hot dip galvanization facility, uses a very similar setup, though it's not with water, it's for their chemical baths. So they've got a chemical bath set up to dip the metals in prior to the galvanization process. It helps clean and activate the metals for this plating. With this, they have multiple dips set up where the more concentrated waste stream is at the end. That's where most of the waste materials are gathered in the first dip process, and that is the one they change most frequently. So that's the volume of chemicals they're getting rid of and treating instead of filling up these tanks concurrently. So this was a very advanced concurrent rinse setup, and definitely one of the really cool ones to see as you watch these metals get dipped. The students had a really good time at this facility in general, but you can see each of these staging areas where they dipped them. And this was a concurrent rinse flow, which again, not water conservation, but chemicals. I thought it was a really good example, though, of what this might look like on an industrial scale. Now, again, these concurrent rinsing processes and water reuse processes don't have to break the bank on large equipment changes. They can be easy operational changes, and we make some of these recommendations on site as small scale first steps to being more water conscious with your facility. So here's a tank storage facility that we worked with in the state. We've got these just about everywhere around every corner. And we offered a recommendation that was reusing rinsed water during tank washouts. So this particular facility used about 8,000 to 10,000 gallons per month washing out tanks. Each of these tanks that they washed out held the same compound, and each one required a few hundred gallons of water to rinse. They would do this over multiple wash stages. So they'd take the first wash down and they'd end up doing that 3, 4, 5 times per tank to make sure that compound was fully removed. All that wash water was collected in a transport tank, which was taken to their holding area before the treatment process itself. So when our team came in, the recommendation we had for their facility was during that first initial flush, that first wash volume, keep it in a separate container and then use that as the initial wash for your other tanks. They're all the same compounds, it'd be the same washout, but in this particular practice, that first flush is going to be the dirty water you use to rinse all the other tanks. So hopefully, saving volumes of water. We recommended about 2,000 to 4,000 gallons worth of water saving each month by using this first flush rinse process. The supply cost was pretty limited. They already had kind of the tank storage they needed, so a small pump to send the water back into the new tanks, as well as maybe a transportation tank if they needed one for the first flush process. Now, one of the big limiting things for our sustainability footprint in Louisiana is going to be the cost of water. So we estimated from their utility bills that it'd be about a penny per gallon. The estimations for first flush wash was about 60,000 gallons per year. So an annual cost savings of around $600. From an overhead perspective, they were already out there with the labor washing these tanks down. There was a small increase in cost for the low horsepower pump you would need, but overall not too terribly much on the overhead side. So ultimately for this small project, the payback period was between 4 or 5 years for the small equipment and the low water savings. Again, it was just an operational change. So this was designed for a really easy implementation and small savings, but this particular area had a really heavy water burden. They used an aquifer for their well water. And so a lot of times in that capacity, you're looking at that being used for a drinking water source instead of an industrial source. So it really had a positive impact in the community that the storage facility was taking those next steps and trying to conserve water in some capacity. So very simplistic, easy for adoption, and really nice for the community itself. Now, one of my specialty areas, being in Louisiana Sea Grant, is seafood processors. And so we work a lot with the seafood processors to overlap the academic channels, the academic networks with agriculture and industry processors. So for this particular recommendation area and research area, we're looking at an equipment and a process change in these facilities. And so most of these facilities, when you go to them, they move a lot of water through these sites to push the shrimp shells. They have quite a bit of effluent that comes out at different stages. And again, each of this is a very automated process that uses quite a bit of water. So we're looking at around 500,000 gallons of water per day to go through this process. And most of these facilities, when you talk to them about why their water goals, they're really just looking at understanding the opportunities out there. Because they're a seasonal operation, they are 24/7 when the season's open, really just trying to keep up with the amount of materials coming in. But that also gives us a really great opportunity for when the seasons close to make some of these larger changes in their process for the next season. So, from an implementation standpoint, this gives us a good little 3 to 4 month window to make these changes. And then from the understanding why they actually want to do this, there's a lot of effluent compliance that comes through different areas, different states that we're looking at before it hits Louisiana, as well as sustainable resources, chemicals, water. A lot of them use well waters in South Louisiana, and they've got to treat it with chemicals before putting it on the shrimp. So this causes, more expenses when it comes to purchasing chemicals. From the academic side, when I'm looking at it, trying to apply the resources I have in my lab, we've got instrumentation to help them understand what their waste profile looks like. So we partner with a lot of these industries just to give them a little rainy day data to show what's coming through their facility, what's being outputted in their wastewater effluent, and then really working with them to craft a practical flow of water through their facility. What it might look like if they transition to a concurrent rinse, and how it would help them reduce their volume and create a more sustainable waste product. And the first way we're doing this, and we've done a few pilot scale trials so far, and we're slowly ramping it up, but one of the instruments we have in our lab is a gallery distribute analyzer. And at each of these different effluent points in their facility, we take samples, water samples, and test it for the nutrient capacity. So nitrate, total organic nitrogen, nitrite, and phosphate. And what we're really trying to do with this is figure out what's the most practical solution for them from a wastewater standpoint. Is it treatment? Is it beneficial use? And how can concurrent rinsing play a role in this? We do have a few processors, one shrimp and a few of the fish processors that have dissolved air flotation units. This is a treatment technique for wastewater. Dissolved air flotation uses a coagulant and chemicals to bind different compounds in the water. As it binds, you form a sludge that then gets bubbled to the top and skimmed off. So here's a picture from one of the sites of the protein cake that's formed. These processors are targeting specific proteins that are released by the shrimp shells. And one of the great parts about what we do over at Ag Center is we can provide them some resources like testing for their protein cakes to see where we could possibly use that protein or nutrients as a beneficial source. Now, DAF systems are really good because you can target specific compounds. So a lot of companies, you might use them for oil and grease. Ours uses them for proteins and nutrients. But ultimately, we want to provide them data to show what they have as this particular byproduct in their waste stream. And the chemical analysis we provide them can be used for beneficial uses for this product and also help them optimize the DAFT process a little more. Now, one of the differences between treatment on site and beneficial use is some of our ag processors in the state go through the process of applying for BMPs for land applied fertilizer. And so, land applied fertilizer is a technique where you can go from your facility onto a piece of land and property to provide nutrient enrichment to that area. So, again, we are doing the nutrient analysis for these companies that don't do this practice to show them if it is a potential for land applied. We're giving them this nutrient profile that shows, yes, it could be a viable opportunity and help them with the BMPs to Louisiana ag and forestry. Again, we like to give rainy day data. So basically trying to allow them to understand how it works and how the process might look if they want to scale to that level. Now, overall, why are we thinking concurrent rinsing for this particular process? So again, here the water flow goes into each of these different areas and you come out with this dilute wastewater stream. So a diluted wastewater stream will overall increase the cost of your chemicals if you are pursuing the treatment opportunity for this particular industry. It could also increase the transportation costs for moving wastewater effluent in a land applied practice. A lot of times, transportation tends to be the limiting step in manufacturers utilizing their waste product more efficiently. And so, whether you're trying to reduce the liquid volume of your waste or dry your solid material to make it easier to transport, this is always a really big step that we try to think through as a practical solution for manufacturing communities. A diluted wastewater stream will also decrease the nutrient value per gallon, which a lot of times when we have a processor that wants to move it to a plant nursery, that's the interest for the plant nursery is what is this nutrient value for how much they'll have to take in that partnership. So all really good things that we can quantify for these industries. And then we're working with one shrimp processor, but there's probably 25 to 30 in the state that we can disseminate this information out to kind of in a nice little care package for them. So in this process of concurrent rinsing, if we are turning this around, the overall goal for this project is going to be to concentrate this waste material for a beneficial use or practical treatment opportunities. So we've got HPLCs and Galleri discrete analyzers that do amino acid profiles for the shrimp processors and other aquaculture processors in our state. Again, we're also doing the nutrient analysis for them to kind of show them what the potential is for their wastewater effluent and commodities, and especially if we're able to concentrate it into this nice package of nutrients. We also just recently, hopefully, I guess we're in negotiation period now for getting a new instrument for fluorescent dissolved organic matter analysis. So tracing organic matter through wastewater effluent processes and then through the land applied fertilizer stage to really key in on how those nutrients are being maintained. And that would all be possible through this concentrating of the waste streams. We're also hoping to roll this method out for this fluorescent DOM detection or fingerprinting of wastewater effluent to other applicable manufacturers in the state, from food processors all the way to the chemical facilities. So we're really excited about this, and I think this is a really good picture of how the academic world really ties in with our industrial manufacturers here in the state. Now, overall, moving kind of from reducing wastewater effluent to reusing it, this is a little more of a mainstream technique. So there's plenty of examples out there online for public and private partnerships that reutilize wastewater. That could be wastewater for hydropower or cooling opportunities at nearby facilities. There's also plenty of internal use opportunities post treatment of your water, and the EPA does such a great job. I know sometimes a lot of my guys down here in South Louisiana, they're a little skeptical about logging on to some of the government sites, but we always push them in the direction to, go see these available resources, because all of our agencies, whether they be state or federal, put together really great informational packets. EPA has two on water reuse for industrial applications and basic information for water reuse in facilities. And that's a lot of what we offer to the manufacturers here, just to get those ideas, just to spark that little bit of creativity. And these projects for water reuse, they don't have to be large projects. So think about your water goals. And again, think about what water looks like in your facility as you're coming up with a plan for water reuse. So these calculations are slightly a little bit easier for us on the academic side. And when we formulate these recommendations, we're looking at the saving cost, and that's based a lot on what the cost of water is in your particular area, the percent of water that you're looking at reusing. That could also include the cost of sewerage if you're going to a sewerage system, so reducing the overall volume there. In Louisiana, we have this problem of most of our facilities use well water, so it's a one-time cost to drill the well, and then there's no monthly cost for water. So trying to get them on board for a sustainability recommendation is a little more tough when you can't put a dollar amount on how much it saves. Now, implementation, some of these implementation projects are a little large scale because you're looking at purchasing equipment or renting equipment, but there are plenty of other opportunities to reuse water in a more feasible or practical way. When we generate these payback periods, they can be a little longer than maybe an energy efficiency project. But we always want facilities to understand there are other benefits that this could provide for your given area, whether they be nutrient benefits to land applied, reducing the burden for water in your particular area. And you always consider ramping up this. So if a facility has the mindset or goal of 10% reuse in the first few years, you can always look at scaling this up over a 5-year plan. And this will also reduce that payback period in the long run. So we don't want people to be scared off by the price tag of what sustainability might look like in their area, because it's really adaptable and you can fit it to your facility's needs and your facility's growth from a sustainability perspective. So one of the best industries when it comes to conserving water, in my opinion, we've got a few of these in the state, industrial laundry services, and they do a really good job. There's so much information out there. I pulled this picture, so many different types of equipment and resources they have in their facilities to reuse water because of their actual footprint themselves. And so going to one of the facilities in the state, again, we were able to showcase this new technology, or this technology they use, to our students. They already had the treatment techniques in place, so they had a dissolved air flotation system. And this system was put in place to remove oils and greases from the water before it went to the city sewerage. Now, if you're a facility that's interested in doing something like this and you don't have anything in place, there are plenty of opportunities, I know, at least in Louisiana, for manufacturers to rent equipment and explore kind of where these opportunities might be. One of the facilities recently that I've seen with this would be renting a dissolved air flotation unit for a monthly trial period to see how it works in their facility and how much water they could turn around. For this practice at this location, they were looking at their city water cost and their sewerage cost with the amount of water they were sending, and it was part of their long-term sustainability plan to turn around water. So if you're an industry that might not be in the laundry service, one of the big things we try to do is make sure that different facilities understand there's equipment out there like this meant to do water reuse. A really funny example we actually recommended a jelly bean counter for an insect rearing company to count the insects before they went into the box. So just because you're not in the industrial laundry service doesn't mean you can't use a piece of equipment that they produce. So we're always on the lookout for how technology can be applied in multiple different settings, in multiple different manufacturers. So we think that's a really cool opportunity to kind of explore. So at this laundry facility, their initial goal was to mix with about 80% clean water. So they were only going to reutilize about 20% of their wastewater effluent, and they were going to initiate it in the pre-washing stage. So they were currently, when we went on site, building a holding tank with transfer pumps to implement this practice. Again, they already had the treatment process set up, so it was going to be post-treatment. They implement 20% wastewater effluent back into their clean water process. And again, they were looking at reducing their overall wastewater flow to the sewage system and decreasing the need from water from the facility. If this project, after implementation, showed good success in the first few years, they were looking at scaling it up over their 5-year sustainability plan. Now, we have quite a few different ag sectors here in Louisiana, and most of them do a really good job with rainwater collection and reutilizing water at their facilities. So most of the lumber companies in our area, we've been to quite a few in the recent years because of the drought. They've got to irrigate their lumber to keep it wet. It typically cuts better when the water is wet. And during the 2023 droughts we had, they really saw an increase in cost for water because they ended up irrigating a lot more. So one of the recent facilities we went to was implementing a new project to use stormwater runoff in their runoff ponds over here to apply to the sprinklers that go around their like their wood yard. They'd be increasing the horsepower capacity of their pump to 300 from a current 100 pump unit. So it was a large equipment change over time, but they really saw it as a more sustainable use of water at their facility. So water reuse from rainwater isn't something that is unique to Louisiana necessarily, but we do have a lot of processors that utilize rainwater collection for reuse. Another particular case, I guess, is a steel recycler in the state. For their particular facility, they were in the process of digging out a 5-acre pond to collect runoff water from their facility and rainwater that would then be used to cool their compaction process. So the compaction used a lot of friction. That friction produces the heat, and they used water to cool it down for their machines. Currently, they run on city water, so they're using about $30,000 per month in water. And so collecting this water from the ponds and reutilizing it would help reduce their overall overhead quite a bit. A lot of our agricultural nurseries also implement this practice based on the natural landscape of their land. And so here, this plant nursery, which is one of our manufacturing facilities, collects this rainwater from our irrigation water and rainwater, and sends it to a pond system, and then they'll have zoned acreage around their facility that's dedicated for that pond use. So they're really doing a good job with the immediate nutrient transition that's coming out of there, or collecting those nutrients that's coming from their plants and reusing that, as well as reusing the water. And it's amazing. You talk to some of these guys when we do the field days, and they show you the difference in bills from the 2023 drought to this year or the years past, and it makes a really massive impact being able to collect this water on site and reutilize it instead of tapping into the well system we have here in the state. And then, excuse me. Lastly, from the chemical companies, a lot of them have a secondary pond set up for rainwater collection that can be used as a backup for their fire sprinkler ponds. And so, tucked away in most of our facilities, we'll have this nice pond, and you'll see red pumps going to it just in case of fires. And so, we always like to point that out as again, a reuse for water in the area. One of my final examples, and again, back to kind of my roots from the fish processing world, and looking at ease for how to reuse water comes from a particular fish processor we worked with a few years ago. This was just a small processing change from the implementation side, but typically every day around 50 to 60,000 gallons of oxygenated water was used throughout their facility. They bring in these 18-wheeler trucks, and they're full of live fish. Those live fish are kept in these tanks of water essentially, and that water is highly oxygenated to keep them alive through the transportation process. So when they emptied these tanks, that water went into a pipe, and that pipe went directly to their treatment process. So it went out of the facility to their treatment process, got mixed in with their wastewater stream. And when we were at the site, we realized that there was a really good opportunity just to send this directly to their wastewater treatment ponds, because it had no BOD, it didn't have the compounds they were trying to target to get rid of. It was just highly oxygenated water. And so by doing this, they would have seen a decrease of about 20% of their wastewater effluent volume. That ultimately would decrease the chemical cost that they were using for the coagulants. But we also saw the added benefit for increased aeration in the ponds because of the highly oxygenated water. So at some of these other locations, we've seen that water volume can increase the chemical use. That's the coagulants and chemicals used to target the contaminants by 25 to 30%, depending on the water volume coming in. You see some of these DAFT operators say that, oh, Joe's running the unit today, and I know I'm going to have to increase the chemical use because Joe uses a little more water. And it's really funny to hear them, the problems they have with water coming into the treatment process. So this, recommendation was very small scale. We just told them, try to push this water just a little further into your ponds. This also serves as an eliminating mixing of waste streams, and benefits the overall pond health by having an extra input of oxygenated water, which they're already aerating the ponds in multiple areas, trying to increase that DO content. We also see other aquaculture processors and fish processors in the state utilize their wastewater effluent for different purposes. So a lot of them reuse that high fat, fiber, and protein that they get from their wastewater in fish meal. So they'll add it as a supplement on top instead of sending it to DAFT units. So that helps, impact a byproduct for them and transition it to, less processing and treatment on site and more reuse. Now, overall, when you're looking at, as a manufacturer, how can you take the next steps to sustainability? There's this really big objective of just getting creative with what water looks like in your facility and how you can utilize it. Again, kind of harping on the university programs, EPA does such a great job providing technical assistance programs to universities, the P2 programs, and there are also other agencies. USDA and DOE have similar technical assistance programs depending on what type of industry you're in. But looking in your particular area for what might be a valuable contact to have an assessment done and have students on site and faculty on site. There's also the federal resources. So I kind of touched on it a little bit with EPA extension pubs and web-based resources, but they have some really good guidelines for pollution prevention strategies, ways to reuse water on site, ways to start that process, and potential funding available to make those changes happen. And then finally, from my side of things on the educational materials point of view, I know my ag center over here in Louisiana, as well as most of the other ones around the nation, do BMPs, best management practices for water, best management practices for particular processors. So always be on the lookout for university fact sheets, field days and trainings, and even sometimes you'll get the faculty journal article that's easier to read and goes through a process that can be easily converted in your facility. But I know all the guys that I work with over here, we love hearing from manufacturers. You know, we'll go to a site, we'll make an impact, and then years down the road, they'll reach back out and say, hey, we've got this problem. And so that continued relationship really goes a long way with our programs. I really want to thank everyone for tuning in today and listening to this webinar. I know it was just kind of a brief synopsis of what we have in our state and some of the things, best management practices we see. A really big thank you to ECU Center for Sustainable Energy and Environmental Engineering. Thank y'all for hosting me and giving me the opportunity to talk about what our resources are from Louisiana side. EPA for funding these types of programs. And then, as always, the grad students in my lab, it's always really fun seeing some of the creative solutions they come up with. And the more site visits they go on, the more crazy ideas they have. And so, me as a PI helping them put those from concept to paper and then see the industry actually implement it is a really cool stance from the academic side. Our collaborators, we've got some really great collaborators in the engineering department that work with us on the energy side and help put together practical recommendations. And then ultimately, the industries themselves. We go to so many different industries, and having these guys open the door for us, it's just so great for the students to be able to see what manufacturing looks like in our state, give them opportunities to grow as engineers and, see them transition into their future roles. But also a really great opportunity for the industries themselves to have these assessments done for them and get some crazy off the wall ideas from students, as well as the more practical ones that can be implemented, within a few years. So thank y'all so much again. And if y'all have any questions, happy to answer.
Thank you so much, Dr. Hayes, for your presentation. It was very insightful. Now we have space for questions. Does anybody have a question? Please feel free to unmute your microphone or drop the question in our chat. I see a few comments in the chat. Dr. Tarek says, thank you very much for the informative presentation. Based on your experience, are food manufacturers open to and accept concurrent rinse recommendations without concerns? How do you convince them to implement this recommendation?
That's a great question. So we do, man, students love food manufacturers. Love going to see how the food's made because they look at it on Walmart shelf a completely different way. It depends on the type of process. Typically, they're a little more reserved when it comes to anything that actually touches the food. A little easier when they're a seasonal processor like we have in Louisiana, but we have done quite a few concurrent rinsing recommendations for like canning industries where they dip the cans to make sure there's no leaks. So I think it really just depends on the process itself. And I think the way we typically unfold a process like this is, small scale. Will it work at your facility? Where do you see that water practice being? The two or three that I'm thinking of off the bat, we have a bean manufacturer and canned gumbo manufacturer that have used the tanks, the concurrent rinsing tanks that overflow into one another when they're packaging. So a little more on the packaging side, a little less on the touches the food side when it comes to food manufacturers. I think that's a little harder with compliance. I hope that kind of answered the question.
Thank you so much. I have another comment here. What are the key operational parameters that influence the performance of a dissolved air flotation DAF system?
Great question. We get a lot of DAFT questions around here, and they can be tailored to your facility. A lot of things we look for or really try to help manufacturers understand is optimizing your DAFT unit for the flow of water coming in. So, a processor that does 5,000 gallons a day versus 500,000 gallons a day are going to need different operating systems. Also looking at the coagulant needed, the chemicals needed, that can all be optimized. A lot of times, if you have a third party that'll do a rental for you, they do a lot of the calculations up front. And then after they do their initial calculations, you can do a little bit of optimizing for your water volume coming in. So that's something we're trying to do with the shrimp processors. I just had a meeting 2 or 3 days ago with one to show them what the chemical signature of their protein cake looked like coming out, and kind of pointed out the excess in one of the compounds that they're using as a chemical coagulant, and how we can scale that down for the phosphate and the proteins we know are coming in. And so that's, optimizing is something you do after the fact, but really volume of water coming in and the concentration of your target chemical.
Yeah, we are facing the problem how to convince the organizations, because water cost is very cheap here in North Carolina.
Yeah, we've got a very similar problem here, and especially because we use a lot of well water. A lot of times, depending on the size of the manufacturer, from the mom and pop perspective, it's really easy to convince them that it's for community goals, community building, so that kind of environmental justice component. And for the larger manufacturers we talk to them a lot about supply chain. Right now, CO2 life cycle analysis for CO2 is really big. You look 5-10 years down the road, it might go to H2O. There might be a big emphasis on water. And so we try to make sure manufacturers understand that sustainability isn't today, it's not tomorrow, it's forever. And so, if they have goals, even if it's, maybe not cost efficient, cost effective, maybe it doesn't save them a lot of money, from a sustainability standpoint, it really helps the communities in the area, growth of your company, and overall positive impact of your company. We have those conversations, and I think it opens a lot of eyes, because a lot of people don't think about it like that. Some of our seasonal companies, they're thinking about what happens tomorrow and the next day, because they got to make it to the next month or the next season. And I think sitting them down and talking to them like that really helps open the door for more sustainable practices.
Problem is making the sustainability popular is a big challenge. If you can make that, everything can happen. Making the sustainability popular is a big challenge.
I agree, and it's been, you have really fun conversations with the guys down here, especially on the agricultural side, about sustainability. And it's kind of like with the life cycle analysis. Companies are having to get on board and being pulled on board. And so from a sustainability side, we're trying to make sure that no one ever gets pulled on board. It's that active choice to make the sustainable decision up front, tailor it to what they want to do goals wise, and why they're undertaking the project. I think that really helps kind of get them excited a little faster than, we have to do this, we have to be sustainable. No, you can actively be sustainable, and it can be one step at a time. One step might be,
Sorry, we have the fire alarm. I'm sorry. We have the fire alarm in our office. Need to go out. Sorry.
sorry, going in and out a little bit. I'm trying to look at the chat as well. It looks like, do you assess the thermal energy savings in situations where you recommend reuse and reduction of hot water? Yes, I will say that. That's my engineering team that does that. So I look at water volume, and they look at thermal and energy savings with the pumps that we utilize. It is a really good practice. We do a lot with heating, whether it's steam or water in a facility, reutilizing waste heat in facilities. That's one of the big things we try to target when we go in there as a unique recommendation. Also in the chat, FDA regulations are really big. And that's something, again, we're in the market of trying to provide ideas for next step. And a lot of the processors down here, a lot of the agencies really work hand in hand when it comes to, is that an applicable practice or something that can be implemented in our facility? I do like to avoid wastewater charges. That implementation of IoT, like water quality, real-time sensing, really helps with avoiding like compliance fees or penalties for too much nutrients, too much DOM, or DO on the outflow.
Thanks so much. Does anybody else have a question? I think you answered everything from the chat, right?
I think so.
People are sharing some feedback. Thank you so much. Excellent presentation. Thank you, Dr. Hayes. Any other question?
Yeah, I really appreciate the audience's time. And, if you ever have questions, the Water Quality Extension Lab at LSU, that's the website you can go to and see what our team does, see some of the things we implement, projects we're working on with manufacturers. So
we appreciate that very much. And thank you so much for your time today. Thank you to all the participants that were able to join today. If you would like to leave another question there, please feel free. Otherwise, follow us on our social media to stay active with our events. We're pretty active on LinkedIn and Facebook. We will post our recording on Facebook so you can see this later on. And we will send you as well the PowerPoints for this presentation today. Thank you very much. Do you want to say something else, Dr. Michael, before we leave?
no, just thank y'all all again. I really appreciate the time and really happy that I was able to share our opportunities from the state with y'all.
Thank you. All right. We are going to end the session. Thank you so much. We'll give you 5 minutes back. Have a great rest of the day. Bye-bye.